Road to Olympiad.
Welcome to RTO. Consider the following problem. Let a, b and c be rational numbers such that a plus b cube root of 2 plus c cube root of 4 is equal to 0. Prove that a is equal to b is equal to c is equal to 0. Tomorrow is Pi Day, so we have Pi Day special today. And let's talk about irrational numbers. Even though it's pretty obvious that the cube root of 2 and the cube root of 4 are different irrational numbers, but are they really different? How are we going to prove thoroughly that the only solutions for a, b and c for the above equations is the trivial solutions? Pause the video if you'd like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, without loss of generality, we can assume that a, b and c are all integers. This is because if they are rational numbers, we can always multiply the entire equations by the lowest common multiple of the denominator and turn the coefficient to integers. Now, if a, b and c are not equal to 0, we can further assume that they are not all even. Else, if they are all even, we can divide them by the greatest common power of 2 to make at least one of them to be odd number. Now, recall that if we have x plus y plus z is equal to 0, we can cube both sides of the equations to get this one, which we can simplify into x cubed plus y cubed plus z cubed minus 3xyz is equal to 0. Or simply x cubed plus y cubed plus z cubed is equal to 3xyz. Substituting x is equal to a, y is equal to b cube root of 2, and z is equal to c cube root of 4, we have a cubed plus 2b cubed plus 4c cubed is equal to 6abc. Where we can write a cubed as the subject such that a cubed is equal to 6abc minus 2b cubed minus 4c cubed. Here we notice that a cubed is even, and thus a must be even. So we can have a is equal to 2a1 for some integer a1. Substitute that into our equations, we now have 8a1 cubed plus 2b cubed plus 4c cubed is equal to 12a1bc. Dividing the equation by 2, we have 4a1 cubed plus b cubed plus 2c cubed is equal to 6a1bc, where we can rearrange and make b cubed the subject, as in b cubed is equal to 6a1bc minus 4a1 cubed minus 2c cubed. Here we can conclude again that b cubed is even, and thus b must be even as well. So we have b is equal to 2b1 for some integer b1. Similarly, we can substitute this back into our previous equations and obtain the following results, where again we can divide the entire equation by 2 and make c cubed the subjects, and comes into the conclusion that c cubed is even and thus c is even. Here we reach a contradiction since our assumptions suggest that a, b and c are not all even, and therefore this implies that a, b and c have no solutions other than the trivial solutions, which in other words, a, b and c must be all equal to 0. And this marks the end of our solutions. Post in the comment below if you have any thoughts on the video. And if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.